Welcome. In this video, we're going to use the method of Lagrange multipliers to locate the extreme values for this function f of xy equals xy, subject to the constraint x squared plus y squared equals 10. When I'm done, I'm going to show you what this looks like using technology. And those of you in my Canvas course, there's a link to this applet within the Canvas course. It's there, you'll see it. Those of you watching this on YouTube, hopefully I remember to paste the link in the comments below, or not the comments, the video description. Well, let's begin by outlining our strategy. There are a few things we need to do. The first thing is let's identify the constraint function, that is, identify actually the objective and the constraint. Well, the objective function is just f of x comma y equals xy. The constraint is given by x squared plus y squared equals 10, and we're going to rewrite that as g of x comma y is equal to x squared plus y squared minus 10. So really, all I did was subtract the 10 from both sides. Okay, next, let's compute the gradient of each function. I'll do that here. So the gradient of f is equal to yi plus xj. The gradient of g is equal to 2xi plus 2yj. Next, we're going to set up a system of equations and solve them. So our system of equations is going to be given by setting the gradient functions at a particular point equal to each other with a constraint, that is the gradient of the constraint multiplied here, that looked like an x, by the Greek letter lambda. And we also want our original constraint function equal to 0. Okay, so what does that give us? That gives us y naught I plus x naught j is equal to lambda times 2x naught I plus 2y naught j. All I've done, as you can tell, is just put in x naught, y naught in place of x and y respectively. So what does that get us? The I components will go together. That tells me that y naught is equal to 2x naught lambda. And this tells me that x naught is equal to lambda times 2y naught. Okay, let's solve these for lambda, and I will get to this one. I will get to this one in a second. Just give me a minute. So solving for lambda, I have lambda is equal to y naught divided by 2x naught, and lambda is equal to x naught divided by 2y naught. So from this, I get that y naught over 2x naught is equal to x naught over 2y naught. And finally, that gives me 2y naught squared is equal to 2x naught squared. Okay, and I can simplify this further to x naught squared minus y naught squared is equal to 0. Now, if you don't see how I got from here to here, pause your video and take a moment to work this out algebraically and take as much time and use as much space. You might need more space, you might need less. Those of you in my class need at least this much space because I want to see at least this much work. So you might need more or less to complete this, but pause your video now if you don't see how we came from here to here. Okay, you should have paused your video, and while you did that, I rearranged my screen a little bit. So we've done this portion here. There we are. And now let's work on this portion here. That is, let's set our original g function. I'll just keep this in orange. G of x naught, comma, oopsies, excuse me, comma, y naught equal to 0. Well, remember, g of x comma y was equal to x squared plus y squared minus 10. So we have x naught squared plus y naught squared minus 10 equals 0. Now, from this combination of equations where we combined our lambda equations here to obtain x squared minus y squared equals 0, well, from this one, we can end up with x squared or x naught squared equals y naught squared. So I'm going to go ahead and replace, I'll start with x naught, replacing it with a y naught squared. So we have here x naught squared plus x naught squared, excuse me, I shouldn't do it that way, there we are, minus 10 equals 0, or 2x naught squared equals 5, so x naught squared, I did division first, excuse me, 2x naught squared equals 10, this plus this is 2x naught squared, and then I added 10 to both sides. There we are, I was skipping a step in my head, so that equals 5, that tells me that x naught is equal to plus or minus the square root of 5. Now, to get y naught, it's a little bit easier. We can just go ahead and use the fact here that x naught squared equals 5. So I know x naught squared equals 5, so that tells me that y naught squared equals 5. So y naught is equal to plus or minus the square root of 5. Okay, so we have solved our equations. And now let's locate all the extreme values. And I'll do that right below. Well, our possibilities are the square root of 5, comma the square root of 5, and also the square root of 5, comma negative root 5. Since remember, we need our positive version of x with both the positive and negative version of y. And now I'm going to have the negative x naught value with both the positive and the negative version of y. Okay, so let's go ahead and do that. So negative root 5, comma root 5, and negative root 5, comma negative root 5. So those are all the possible extreme values. And now I want to remember that our original x function, our original function, x comma y, was equal to the product of x and y. So that tells me if I say put in root 5, comma root 5, I end up with the product of root 5 with itself, which is 5. If I put in root 5, comma negative root 5, I end up with the product of positive and negative root 5. That'll give me negative 5. And I'm just keeping these in correspondence, see, here. So these two will go down below. So f of negative root 5, comma root 5, that's going to be negative 5. And f of negative root 5, comma negative root 5 is going to equal 5. So as we can see here, these two are maximums. And this one are minimums. Let me make a little more space so I can write out the results. All right, you can see that I made more space here, so let's write out our result. Or conclusion would be a better word, actually. Let me do that, conclusion. There is max, so max is at the point root 5, comma root 5, comma 5, and negative root 5, comma negative root 5, comma 5. And the minimums are located at root 5, comma negative root 5, comma negative 5. And I should write smaller here. Negative root 5, comma root 5, comma negative 5. So as you can see here, I have the applet I created in advance open. Here is our function in this bluish color. There it is. Here's our constraint. And then you notice there's this black line here. So let me hide these and leave that black line. This is where our function intersects the constraint. So we're looking for maximum and minimum values of our function along this curve. Okay, so let's show our function again. See this curve on the function. We're looking for its maxes and minimum values because that is where it intersects this cylinder here. Okay, so with that, I already have the mins and maxes here. Here's one max, and here's the other. And let me hide the curves. Those are certainly maximum values, and here are the minimum values. Oh, excuse me, look at that. These I made exactly the same. By the time you see this, it'll be fixed. So when you open this and you switch D on and off, it'll be in the correct spot. So there you have it. There is there are two maximums and two minimums on our function x times y in xyz space, given this constraint here. Well, hopefully you found this video helpful. Please keep calm and math on.